This is Ed Robinson at Kensington College, continuing our lessons on C++, the object-oriented aspect of classes. Today in particular, we'll be talking about the overloaded operator. When we overload an operator in this case being the plus sign, when we overload it, we give it a meaning that a custom meaning that we are going to define. At the moment, plus means like add two elements together, but in this case we're adding two objects together. Now here you have an object P2 and an object P1, and you're adding together two objects. Now how on earth can you add two objects together? Well, it's up to us to define how to do that, and that's the meaning of overloading the operator. We have a class called part, and let's just revise how we create objects of that class. I'll just comment out my overloaded operator line for my line for the moment, and we'll just concentrate on what's going on, just revision indeed. So I'll put a breakpoint here and revise just how we create objects. We have a class defining our objects P1, P2 and P3, which hasn't been initialized. So if I single step this, we'll just revise how P1 is created. It passes 1 to here, which indirectly gets passed to I. You could say that line means I equals j, and this is how we initialize using the one argument constructor. So I'll just continue doing that, and you can see that P1 in the autos has been initialized to 1. The S, we don't really deal with S, we should really just comment that out really. But continuing, we have then P2 is created, and then finally P3. Now P3 obviously goes to the no argument constructor up here because we haven't initialized it at all. Let me just show you while we're here a little thing which you might consider to be strange, and that is initializing an object. I'll just comment out this little bit here so you can, and then what we're going to do is just, well, that bit there actually, the whole thing, and what I'm going to do is just, you might think, take rather a liberty, because I'm going to initialize an object, but I'm not going to give the object a name and just see if that still works. You wouldn't expect that to work really, so I'll just build that. And then if I just run that down to the, you'll see it does indeed work, so I will just put a breakpoint here and run it to there and see what happens. Well, if I F11 here, then indeed I've created an object that's called this. This means the current object, but it hasn't got a name like P1 or P2, but still you can see that the J has been passed here to 1, and this line of course means I equals 1. So it looks like you're initializing. I'll just single step again and then come out of that, and you can see, well, we missed it really. I'll just run that quickly again, and you can see I wanted to show you this on the right hand side. So I'll F11 and you can see this here. Now this means the current object, and it hasn't got a name, so but you can see that now that I of this object has been made equal to 1. Well, what's the point of all of this? The point of all of this is that you can create an object here on the fly without allocating a name to the object. So that's a notation you can just get used to. Okay, so back to normality. Let me just, this is how we normally create three objects. One is being P1 is being initialized, P2, and P3 hasn't been given a value to its I. I'll just uncomment this because this is what we're trying to do. We're trying to add together two objects. Now you're going to say, well, that object has got two data members. How do you add together an object? Well, it's up to us to define it. Let's say we'll define it so that it will add together the I elements. Well, we need the overloaded operator to be inserted here. Let's take a look at that. it says we're using the word operator. Always when you're overloading, which is what we're doing to this plus sign here, we indicate that we're overloading the plus sign by that notation, overloading and then plus. What are we passing? We're passing to it P. Now we're passing it the thing on the right hand side, which is P2. I'm going to do this in slow motion in a moment, but that's what happens. You see, how do we call a function in C++? Well, in this case we've got a plus sign which has the effect of calling a function, and it's strange notation, you'd say, for calling a function, but you're calling a function and passing P2 to the argument P. We'll have a look at that in more detail. But notice that I'm using the word part. What is part here? Part is the return type, because we're returning an object to P3, which is the addition of the two objects. As you can see, we're returning an object here, part k, which I'll come back to, but you'll notice I'm defining an integer k here, and then I'm using that to add together the two integers. We could subtract them, we could do what we like with them, but in this case we're adding together two integers as giving a meaning to this plus sign here in the overloaded operator. So let's single step this. If we'd better build it first to make sure that it's working okay, and then I'll put a breakpoint in and run it to the breakpoint, and at that stage we've initialized all of our objects P1, P2 and P3. We haven't initialized P3, we've created an object P3, and so now if I F11, we need to watch carefully what happens here. F11, it goes up here. Now what is P? P is P2. P2 has got the value, its I value is 2. Well, I can see that over here actually. I can see that P has its I value is 2. So that's important to understand, that P2 has been passed to P. Why? Because it's on the right hand side of the operator. Now if I F11 once again, K you see will be initialized to 0, but now it's become 3. Now how did it become 3? Now take a look at this. You see, if you look carefully, P's I is 2. That's because P2 was passed here, and this represents P2. What is this one? This one is I of 1. Now where did that come from? Because this is like the internal value at the moment, shall we say. Where does it come from? It comes from P1. Why? Because P1 called the overloaded operator. You'll remember that when we use the P1 notation and a dot and then the name of a function to call it, well, you can imagine that's the same sort of thing, because P1 is calling it. It's before the plus sign, so this is the one which is calling the method or function. So the point is, this I here belongs to P1. Why? Because it's on the left hand side of this overloaded operator. So now you can see that K is the result of adding together the two. Now this line here, as I indicated before, we can initialize an object without actually naming the object. So this is what's happening here. This is why I just introduced you to this a moment ago, because now if I F11, you see it goes and creates a temporary object whose I value should be 3, and of course the J value is 3 as well. And now, having created our object, now we'll throw our object back, rather like a football, throw it back to our P3. Why P3? Because P3 is on the left hand side of the equal sign, and when we return our object and we set it's a part object which is being returned, the object P3 has got the value of 3. Let's just check there and see what the value of its I is. At the moment it's 0. So if I now F11, you'll see that P3, its I has been given the value of 3. So that's how the overloaded operator works. It might be a good idea to try an exercise which will provide a practical application of the overloaded operator. We're going to make a class called coordinates, coords, which will hold two integers named x and y. You want to create two objects, you can call them C1 and C2, which are going to hold the values represent the coordinates 1, 2, 2, 1. Let's say they're called the data elements are x and y. Make a third object, C3, which will hold the result of the addition of the two coordinates. So that when we have something like this, C3 is C1, it'll actually be adding both the x's and the y's. So try that yourself. You should find you get something like this answer here, the x coordinate being 3 and the y coordinate being 3, because you're adding together these two coordinates. If you could also consider these as vectors. We could talk about that a bit more once we've done this particular problem using just coordinates. So try that yourself. You could pause the video because I'll then go on to show you how it's done. Before I show you that, I'll just show you how to move the overloaded operator outside the class, which you remember we've done previously with the scope resolution operator. So if I take that overloaded operator code and place it outside, I'll copy it and place it outside, copy it rather than cut it, so I'll put it outside the class, and then you recall that we need to leave a prototype inside the class with the semicolon, and we also need to qualify it with the name of the class. So notice this is our return type here, and this is the bit that's saying the class it belongs to using the scope resolution operator. So if we were to build and run that, you'd find it does exactly the same thing as previously, but our overloaded operator code is outside the class. So we might as well use the code that we've got to solve our problem. We'll just get rid of the overloaded operator code. And we want to create an object called coords, which is going to hold two integers, x and y. We'll make two constructors, a no argument constructor and a one argument constructor for each of x and y. Well, we have now a two argument constructor initializing x and y, and we'll create three objects of that class, and eventually we're going to add them together. But before we do our make an overloaded operator, we might just make a function to print them out, print the result out while we're here, which might look something like this inside the class. And then we want to print out each of those, so we'll do that in main, just to check that we've set up our objects okay. We could just print one of them out. Well, we could build that, and then when we run it, of course, we'll just have the values have been initialized to 0, 0. They're the values of C3. So now we want to add together our two objects. And it should complain about that because we haven't got our overloaded operator code yet. So we could make our operator code to add them together and paste it in here. We can then build and run that, and it's given us the correct value that the x is 3 and y is 3 of the new object C3. So we've effectively added the two coordinates together. You may wish to simplify the code as we did previously, where we don't really need to create this temp object. We can just create an object which doesn't even have a name and pass it these two integer values to initialize. So we won't need that code. You can see now how that can all be simplified, and that should just build and run as previously. Let's now discuss concatenating strings using the overloaded operator. You'll recall we've been using this in the past when we used a method to concatenate. It's a bit clumsy, so what we really want to have is this statement here: S3 is S1 plus S2. Well, we're going to do that using a little bit of smoke and mirrors, but just for the moment let's see how, and this is what we eventually want to do. We want to add those two strings together, so this program won't work at the moment. There isn't an overloaded operator, but let's take a look at, we want to just have a look at initializing our strings round and about, and we've got a constructor, an incomplete one, and here it's a one argument constructor, so we've passed the value of s to here, but you might be tempted to have something like the internal string str equals s, but don't be tempted to do that. It just won't work. It doesn't really know what this equal sign means in this case. And you might be tempted also to have something like this. When you're initializing it, you want to initialize the string to a null string. That won't work either. So what we have to do is to use our string functions to initialize, which we do like this. For the no argument constructor, we can use the string copy function, which copies the null value into the string. And for the one argument constructor, we can do a similar thing, but we copy, this time we're going to copy s, which has been passed to it, into the internal variable, if you like, str. So that's how we use our constructors to initialize the two strings. And now how are we going to make an overloaded operator which will cope with this, with s1 plus s2? So we'll start off with something like this, where I have the word operator followed by plus, indicating we're going to add them. It's going to return a string type, and we're going to be passing a string type as well, which is going to be the s2 is going to be passed from here. S2 is going to be passed to ss. So we're obviously going to need to return some string temp, which is in this case, which is going to be returned to s3. So in the body, we're going to create our temporary string, which is going to be passed back, and use the string copy again, where we're copying the str into the internal, if you like, variable of the string. It's the member element, the member of the class. So let's see how this works. I'll put a breakpoint down here and then run the code down to here. Now S2 is going to be passed to SS. Let's just see if that's true. If I press F11, then you'll see that SS is about. Now notice that because it's the plus sign is more or less calling the function, then this is actually what's on the right hand side as an argument, if you like, being passed to SS. Then we have F11 again. We've created our temporary string object, which is going to be the one which is returned to S3. Now So I'm now creating my temporary object, initializing it to a blank string. I've made an error here. I'll have to stop it, or I can jump out of that, debug, step out of that. I pressed F11. I shouldn't have done that. So I'll step out, and remember to press F10 in future. So if I F10, it's now going to, what have I got here? str is the string str which has been passed by virtue of S1 being on the left hand side of the plus sign. So str is like the member function of the class, which is this here is the member. It's like internal, if you like, to the class. It's being passed to our temp str. Now, temp str at the moment is uninitialized. Well, it's a zero length string. So this is going to be directly passed to here. String copy works from right to left. This is copied into this. So I'll just F10 again. Now this time we're going to concatenate. So this thing here is our about, and this one here is our round. And this is going to be joined, this bit is going to be joined to the end of this bit. So I'll F10 again. And now if you look at temp, you see its string is roundabout, which is what we want. So this is what's going to be passed. If I just F11, that's going to get passed to S3. So S3 you can see is uninitialized. Well, it has a blank string at the moment, and then S3, if I F11, you can see that S3 now contains the string roundabout. So you can see what I mean by smoke and mirrors. It looks as if you're adding together two strings, but what you're actually doing is adding two objects which contain the strings. Now you might say, hey, that's a bit of a waste, isn't it? I've only got one member function, which is str, but the object encapsulates, if you like, that string str. So it looks like you're adding together two strings, but indeed you're adding together two objects which contain the strings.